Well, hi, good morning, and thank you so much for joining me here in my shop. Today is June 14th, and what we're going to do is we're going to try and power up this car radio using shop power supplies. The vibrator in this radio, here it is right here, doesn't appear to work. So a new electronic or solid state vibrator is going to be purchased and installed in this radio. In the meantime, what I'm going to do is prove the radio works by powering it without the vibrator in the power supply and just using a shop radio supply to supply the high voltage, which will be missing otherwise. Okay, just getting all the parts out of here. I will set this up, and here it is here. Okay, we'll set this up and that's kind of odd, isn't it? That would move independently like that. Maybe not. Okay, not gonna worry about that. Okay, speaker connections here. And then there's a power connection. This cable. Okay, so I have to supply it with 12 volts. The 12 volts are used to operate the tube heaters in the radio, and then I have to supply it with an additional voltage which will not be supplied by this. And I should be able to feed the power in the right spot here. The right spot. I have to find the right spot. That's a bit of a trick. So let me stop for a bit. Actually, you know what I want to do? I want to pop the vibrator right out of here. Put him back in his can. And he's got a bunch of rubber sound vibrating insulating stuff. I won't include that right now. Okay, I should study the schematic a little bit and then make some decisions about how to do this. Oops. So, down here is the power supply. The vibrator, the AC that's developed is fed into this transformer. It comes out. And we have the 1600 volt capacitor here. There's usually another one, I think. But anyway, there's that whopper there. There's one over here which I didn't put a rating on it. I think this one has to be a high voltage one also. And we come through the OZ4 is a rectifier. I didn't realize that. It's a gas rectifier. And then you get 280 volts coming out the other end of it. Wow, that's a little higher than I expected, but that's okay. So all I got to do is if I can just pick this terminal here that says 280 volts and attach a 280 volt source to it. Could be pins. This is the OZ4 here, and it looks like the pins are almost accessible there. Another good spot would be the power plug. Now they're showing this. That's probably the socket they're showing here. But I may be able to look. You can see these two that are very close together of the three contacts there. One of them goes to ground. You can probably see that, and then I know the other one is the 280. Do I even need this power supply at all? Well, the speaker's there, but that's a separate matter. I don't know. I don't think so, because you're bringing over the low voltage you're not going to use, and then we're sending back the high voltage. So all I got to do, bear in mind I'm looking at the plug now, and you know, I can probably tell which one of the two are grounded because they're probably grounded right. I can probably prove it with a voltmeter here. Ohm meter rather. I would guess it's this one, grounded, and the other one not. Oh, what was that? They both show ground. Was not expecting that. So I'm testing. So only one of them should show a ground. The other wire just comes to this tube. Doesn't go anywhere. One to ground and one to just nowhere. How come both are showing a ground? What am I doing now? I'm testing the radio, not the power supply. I'm testing the radio, not the power supply. Hello, hello. Let's test the power supply here. So by my reckoning, well, one of these two should show a ground. Not that one, but this one. Not this one, but this one. Neither one shows a ground. What the heck? Kind of hidden from view under there, of course. So if this is a coil, these are two capacitors here. There's a red wire coming off the distant pin, the lonely pin. And it goes to a pin on the OZ4. Oh my gosh! And the other, the wire coming across to this coil. It looks like. And then what about the other one? Oh, we can see it from up here too. Let's look in there with a better camera. see what is going on here. This isn't working out all that well either. Flashlight, please. My flashlight is taking a walk. I don't know where the flashlight is. Turn these guys up here. And what I'm going to do is I'm going to take control of the focus on that camera since it's not cooperating. Seldom does. Okay, I've got control of the focus here. Capacitor and a resistor onto one terminal. Behind it, you can, on the left, you can see another terminal with a wire coming to it, and the tail is sticking out. And then to the right, at the very top of the picture in the dark, is the last terminal. That's the one we want to see. Okay, so I'm going to look from the other side now. So you can kind of you can see what I'm doing here. Okay, I'm going to try to adjust the focus while I'm... Jeepers. I'm doing this with my left hand on the mouse. I'm right-handed. Okay, there. Come on, give me some light in here. So that's the back of the tube socket you're looking at right there. And the thing I'm looking at is further down. Isn't it? No, it isn't. No. Got it wrong. That is the plug. Okay, so one of them, so we're looking at the other one now. The one we couldn't see. It's got a wire coming out some distance and then it just disappears into the darkness. Where's my flashlight? Who took? I'll bet you a cat took it. They've been running around the house playing with the flashlight. Oh, I can see lots of stuff knocked down over here. And there is the flashlight. Right here. I found it. Okay, let's see what we can do with this. Not adding much. They've just managed to cover this thing with metal everywhere. I'm gonna have to use my so there. So you see the wire going into a sleeve. It's the other terminal. I thought it was the other terminal before. From the what happened there? Every time I do this, it's the other terminal I can't see. Focus is off again. Okay. Hold still there. Okay. Red wire, the lone connection, the two close ones are, oh my god, I can't operate the camera here. Can't see a thing. It's useless. Totally useless trying to use that camera. That's not working at all. Abandon that attempt. Okay. I got my flashlight now, so I should be able to see. All I want to do is see that that other terminal is grounded somehow. big blob of solder on it, but I cannot see anything going anywhere. So it could be it's soldered right to its frame right there. They could have bent the terminal over and then solder it right onto the frame, and it's just going to look like a blob of solder. Oh, I can see it. Finally. Okay, that's exactly what it is. They bent over the grounded terminal. Grounded terminal is the one on the left here. Why is the other one showing a ground? The other one Just sit there. Just sit there. Why is the other one showing a ground? Why is the other one measuring a ground? It should just be a wire to an open pin. And, oh, this is a gas-filled tube. Are they conductive? Just like that? I think you still have to heat them up a bit. I'm not sure. I am not sure. So pull out this tube and see what happens. How come you can get a ground on both those terminals? Let's double check that test because it does not make sense. Oh my gosh. And I'm getting a little frustrated here this morning. Whoops. Sorry, just banged the microphone there. Sorry about that. Why the feelings of frustration? You know why? Because underlying factor here is I'm rushing. I'm rushing, and so I'm feeling the every delay it bothers me. That's what's going on. Okay, stop rushing. Okay, watching the meter. This one is grounded. This one goes to the tube. Oh, look at that. It's not showing ground now. What the heck? That's the one I need to connect to. But not there. Back in the radio. So we take the plug. We've now proven which one is the ground. Matches the the live one. We've proven the live one. Jim, don't get confused now. That's one of my favorite things, getting confused. We've grounded. This won't go in there, will it? No. Too big. We need something to go in there and sit. We need some chance. Is this the right diameter? Nope. But I bet you this might be. Okay, good. I put it in the wrong one already. Okay, think about that. Don't get this wrong now. So you're plugging it in there. This is the live one. You're plugging it in there. This will be the live one here. This is the one I need to put 280 volts on. I hope I got it right. But I put it on the wrong one. The other one's grounded, so I'll find out pretty quick. Okay, that was great. It's an awful lot of effort to figure out something simple. But you don't want to get it wrong. Okay, so I'm just in time now to have some company show up, and I think I'll do the rest of the setup, just hooking it up to the power supply and get everything ready to go. And I have to go turn the coffee maker on. Oh, Bert, what are you doing now? Oh, take it easy there, buddy. Come on around here. You see that bird is even bigger? He's bigger, and he's even bigger. He's getting bigger like every day. Okay, you want to go down. There you go. I'm going to go and tend to the coffee, and then we'll get this thing set up. Without even drinking any coffee yet this morning, we're going to try and power this guy up now. So I have the low voltage 12 volt supply over there, and I have a high voltage supply up here. Just move this cat affected wire. This is the high voltage supply. Flip it on to standby. This controls the actual voltage going out. Has some meters on it. They're not very accurate, so I have another meter here which is going to tell us the actual B plus right at the radio. 280 is what it said on the Schematic, that's pretty high. I'm sure the radio will work with much less than that. So, process here. So we would heat up the tubes first with that. Turn it on like this. As for the automatic tuning, I'm not sure what's going to happen with that. Let's see. Yeah, did I mention it? This radio tunes stations automatically. You just push this big bar here, and it'll hunt across for the next station. That was the big attraction of this radio, self-tuning radio. And of course that makes sense. You're driving a car. You can't be doing this. So you just reach down, hit this great big bar, and off to the next station. Okay, so I'm going to switch on the power supply for the tubes. I'm going to raise it up. I think it is at 12 volts already. Give it a moment to heat the tubes up, then we'll start applying B plus voltage. We'll make sure the meter is showing a positive here. Turn on and we'll head for 100, 150 volts or so, and we should hear something from the radio at that point. Particularly if I've turned it on by then. Okay, I think we're ready. Okay, I'm just going to reach across and turn on the power supply over here. Okay. Now you can hear the cooling fan going in it. I'm going to turn this. When I turn this, if you're sharp-eyed, and you can see past these wires, you'll see this current meter jump up briefly. True. True. Okay, so now we know the tubes are heating. No B plus in the radio at all. $14 volts leaking out of my power supply up there. It's on standby. This should be 0, but it's given 14. 14's not going to do anything. But it tells us this is the right polarity anyway. I didn't mess that up. Which I'm looking over right now. Okay, we can start cranking up the B plus voltage, and we'll see what we hear. You can just keep an eye on this meter here. Like, oh, I don't have it on stereo. It should be going up. Why is it not going up? You know what it's showing? It's showing the power supply voltage from the DC supply, I think. 14 volts. Okay, something terrible has gone wrong here. Well, I wouldn't say terrible, but how does this happen? What I'm going to do, I'm going to disconnect the power supply here. I'm going to hook it straight to the meter. All the meter's doing is reading the output of the power supply. It's fallen down. There's 14 volts coming out of this radio at that point. I'll turn this up and down just so we can see it go. There it goes, up and back down. Put it back on standby. It does drop to 0. There's 14 volts. There. Why? Because all that effort I picked the wrong terminal? My coffee maker beckons. Well, it doesn't make any sense to me at all what's happening here. I don't think I can look at the schematic and reason anything out. So I've hooked up to these terminals here. This would be the B plus one, driving B plus up through here, up through the output. Oh, this has got a push-pull output in it. I didn't even notice. Lots of volume. Well, there's definitely a problem here. Something wrong with this tube. I can't affect anything. I'm hooking up to the radio. I'm hooking up to here. Maybe I just have these reversed. Oh my gosh, just my cats here. Let's turn off the set. So the two wires that are in this shielded situation here, one of them is carrying 12 volts out to the supply, the other one's carrying the high voltage back. I should be able to look at the end of the wires and figure out which is which. The one that's carrying the 12 out, this is going right to a capacitor here. Looks like this is going right to a tube pin and a coil. There's a coil inside here. Pretty sure that's a coil. Yes, a coil of wire. So we have one that comes right into a coil of wire. One of these two wires is connected directly to a coil. I don't think it's this one. So this way, there's a coil right there. There's a coil right there. So the one that's connected to the coil, that's not at all anything I'm interested in. That's the third. It must be grounded back in the radio. I must be able to detect the ground. Oh, what's that sound? Well, I heard a sound. Sound like a cat, actually. But there's no cats in here. Is there some other animal in my shop now? Okay, I'm going to disconnect that. Is this the grounded one? Back in, it'd be grounded right here. The simplest stuff, but you don't want to make a mistake. And wow, I just got I got red flags flying everywhere. Ground this here. So it's definitely the grounded one, and this is not. Who it is? Well, it may not be grounded. So it's coming down to 5. Oops. We get a 5 or a 6 there. On the other one, we can go lower. Come on. 2 and a 1. 3. It's not completely reassuring, but I think I have this right. Well, why would there be 12 volts there while the radio's operating? Can I see it here? Let's just fiddle around. Here. Turn it back on. Well, check first. Well, I already did. There's nothing there. There's no... Turn it on. That's got to be the DC supply voltage. How could that get to that terminal? Wow. This just doesn't seem right to me. Maybe I'm misinterpreting this, but I just wouldn't expect the heater voltage to show up. And if we follow the heater voltage circuit, they show it on here. So they show, each tube shows a little Y and a grounding mark. So they have one wire traveling through here, picking up the Y pin on every one of these tubes, and the other heater is grounded to the chassis. Same thing here. So now here's a Y here. So Y is connected. That's a Y. There's a Z. There's a Z connected there. This is the 12 coming in. It goes through some stuff. And the 12 is sent straight to the Zs, where it then goes to the chassis. 12 also comes along here, comes into the power supply on the distant one. Yep, 12 comes up into this side, run the vibrator. The ground is on here, which we've measured a couple of times, and that leaves this other pin, the 280 volt one. It's completely isolated back here. But over here, how are you supposed to relate these? So they show this is grounded. So it must be they just relate them directly. And that would make some sense, because the 280 then would be heading up this way. How does the 280 get involved with the 12? Well, when do they ever meet up? They don't. The 12 should be contained to two things: this part of the circuit and all the heaters. Well, I don't know what to think. I don't know what to think here. I could be seeing something normal and I don't realize it. It's supposed to overpower the 14 volts by driving it up to 280. That doesn't sound good, because if 14 is making it to the high voltage terminals, wouldn't the high voltage terminals make it to the 14? If I run this up to 280 volts, I'm going to be sending 280 volts right back into my other power supply. Just guessing. This is not good. I'm not comfortable at all with this. This is not it's not working out. Yeah, I don't know what to do. I wonder. Turn off my high voltage supply and turn this back off. Go get a cup of coffee and wonder about this. I don't know what to do. Well, I've been studying the schematic here. If we take a look at it, I see the 12 volts comes in here, comes to this cable, comes to that terminal on the plug, and comes to an end. That's it there. It also comes down, goes through this coil, and becomes the Y wire that's winding through the radio, picking up each tube here. There's a Z connection here. You know what? I haven't located this. Where's this going? Z connection. A, B, C. Where are you, Z? Maybe you've seen it already, and I'm still looking for it. Well, Z, this might go to the light. Where's the light? There's the light right there. So no, Z, where are you going? Well, I don't see the Z out here anywhere. Nowhere. See parts list for alternate value or application. Let's read down here. DC voltage is measured with a 1000 ohm per volt meter. That's lousy. Socket connections are shown at bottom view. Measured values are from socket pin to common negative. Battery voltage maintained at 12.6 for voltage readings. Nominal tolerance in components 10%, 15%. Volume control at maximum. No signal applied for voltage measurements. Nothing there that's going to help. So how do you get 12 volts onto this circuit here? Well, you can see there's nothing attaching them together. a short inside the socket itself. If you have 12 volt, this is hard to understand. If you have 12 volts here, but I'm measuring a ground on this terminal. So you have 12 volts here and measuring a ground there. You'd be plugging 12 volts into a grounded terminal. Boom. This just isn't making any sense here. None of this is making sense to me. You can't get 14 volts. You can't get the voltage there. You cannot get it. At first I thought the 14 was coming from my DC high voltage supply, but it's not. I am paralyzed. I really don't understand this. Should I just repeat everything and see if I get the same result? Well, that would be crazy. Someone else has worked on the radio, but it doesn't look like they've done very much to it at all. There's something screwball about my negative wire. Did the negative wire come off? Maybe it came off? No, it's still attached. That wouldn't explain anything anyway. Let's turn it on again and remeasure the voltages at this point. So I'm going to disconnect the high voltage supply completely, so there's no chance of it getting involved. Get this out of the way. Voltmeter, wake it up. It's ready to read 60 volts. Don't know where I'm going with this, but I'm going somewhere. Okay, this is off. Turn this on. Okay. Turn this on again. Watch the ammeter. Yep, that's normal. The tubes are warming up. Voltmeter. Okay. One lead grounded. There can be no question that's grounded to the chassis. And the other lead here. There it is. Now what happens if I go in the grounded one? I mean, if I got a voltage there, I'd really be thoroughly upset. So this just simply got it backwards. That this is the 12 volt supply. And somehow I got my head turned all around. So there should be a 12 volt supply coming from here into here. And the high voltage should go back. Let's find the 12 volts here. It's either this one. Oh, wow, okay, 0.78. That's real helpful. Or this one. This one right here. So this appears to be the... Oh no. What's going on there? There we are. There's a coil right here attached to it. 14 volts with a coil. 14 volts with a coil. Oh, I have a layout diagram here. A layout picture of the whole radio? I do. Okay, that might be helpful. Right now we want to look at the schematic. So the wire that's grounded, that would be this one. That would be, where did I go here? So we're dealing with the cable coming back here. I've got this. Finding the ground. I'm probably just getting confused because these diagrams can confuse me really easily. I mean, it doesn't take much, frankly. Obviously. Well, I mean, I could just set the whole thing up the other way around. Well, let's see. If I found the 0 here and I'm finding, what was I finding there? this one. Finding the yeah, finding the nothing here. How did I get that reading? How do you get that reading? No way. Okay, hold on a second now. Isn't so the 12 volts is coming out of this one. Oh, you can't see it. Yes, you can. It's coming out of the lone one, the distant one, the distal one. That's right. You should find 12 volts to ground in there, like so. That did it. How come we don't find it? This plug is not wired correctly? Come on, like that's crazy. That's crazy. So minus 0.7 volts. What the heck is that? That's, I don't know what that is. That's a voltage drop of some sort. There's no current on this. How can it be? What's going on? And then this one, we find just nothing in terms of voltage. And on this one, I mean, I just have to assume that we should find a 14 there. 14. What's a 14 on two of them? Wait a minute. Wait one second here. Oh, shame on me for saying that. I take that back. Okay. Well, for sure, this is definitely the ground because it's a 0. Turn this off. Turn this to ohms. Give the radio a moment here to calm down. I shouldn't. Okay, wait a minute. Switch is off, is it? Is it really off? Yeah, switch is off. Okay, so I can do the continuity check here. This one is carrying the 12. So it should be, turn off the supply there, just let it bleed down for a moment. I'm really just shooting in the dark here. I'm just looking for something that's gonna make me go, oh, now I see. Okay, I want to try continuity now from the supposed 12 coming in. There's still voltage in my supply over there. It's going to take a long time to bleed it all down. It's got big capacitors in it. Can we short it out quickly? Doesn't matter. Does it matter? I don't think it matters because I'm just reading along. Yeah, I don't think it matters. So I should find 0 ohms here. Oh my gosh, I gotta reach in front of the camera. Let me do this. Don't know where I'm going. Don't know what I'm doing. But I'm doing stuff. Okay. There we go. To the positive. The switch is off though. The switch is off. Okay, I'm gonna turn the switch on. That'll drain whatever's left in the supply too. Okay, here we go. This should go to 0, shouldn't it? Shouldn't that go to 0? Wow, it's getting weirder and weirder. And this is the one where we found the 14. Then it goes to 0. But isn't this one, the lone one here, isn't this supposed to be the 0? Isn't this the one that's bringing the 12 over? right from here. You can see it right on the diagram. What's happened here? I don't get it, man. I don't get it. I mean, you can't be wrong about the low, you know, the distal terminal there. I mean, it's standing right out on its own there. And I can see the wire going back. It's just through a coil, but it's wire otherwise. Wire through the transformer. Wire. What? I'm going the wrong way, aren't I? Yeah, I'm going the wrong way. Let's go this way for crying out loud. So we'll come off this top one. It's this wire. I mean, there's just no way to misinterpret this. Straight to the switch. But I don't find the 12 volts in that pin. Well, I'm totally paralyzed now. I don't know what to think. I don't know what to think. Oh my gosh. Oh my gosh, I don't know. I just don't know. Let's look at these two solder jobs here and see if somebody's fooled around with these wires and reversed them by accident or something crazy like that has happened. So, wow, that does look freshly soldered. What am I looking at exactly? Let me put a stick on it here. Is it this one? No, I am looking at, so this white wire is the wire from the cable. You can see this is fresh solder here. And not me. I think it's fresh solder. You can even see that this wire looks like it's kind of barely on there. I think that's original. Now that's one wire. The other wire is up here. Now, if you did that look resoldered? Compared to other solder things, it's not particularly standing out as a. I mean, it could be. It doesn't look a lot different than these other soldered joints. Ooh, that's a new one we're looking at there. Yeah, so that's so I'm looking at this one off this capacitor, which I think is a replacement capacitor. It looks a little shinier than these other ones, a little duller. And then I come back and look at where to go. Here it is. Kind of shiny. So this one is connected to this coil. You can see the coil inside there. The 12 volt in is connected through this coil, isn't it? Can we possibly trace the, wow, the switch is way over yonder. Look at this. We can't. Let me, oh, running out of, standing on the wire to my camera there. So we look at where the power comes in. It's going to be on the back of the volume control here, where the on-off switch is. And we see some, can we see a heavy cable? I thought, I jumped when I saw this, but this is the audio wires in the back there. There's the power wires, but I was hoping they were on a cable. We could see it and follow it right across. I got all excited for nothing. We cannot. This wire here is probably the Y wire that's running from one tube to the next, to the next, to the next, or to this thing, and onward. So that's probably the Y wire. Who cares? I don't care about that. Did somebody disconnect these two wires and then reinstall them and get it backwards? Would that do it? Now that. Let's look at the schematic again here. If somebody reversed the two wires, the two white wires, the shielded cables, The two shielded cables are here. If you reverse them, what would happen? You would find the 12 volts in the wrong terminal. If you reverse those two white wires, you would find the 12 volts in the wrong terminal. Just like I am finding it. We don't know the history of this radio. We don't know anything about it. I found a fault on one of these wires, which is kind of weird too. Like if somebody was to replace this, they had another radio and they took the wire, for some reason they took the wires off and put this wire on, they would have found the fault while they were doing that, and they would have dealt with it. But the fault came subsequently. The fault came subsequently because high voltage was placed on a low voltage wire. So they're both exactly the same. So what would happen if you actually had these reversed and just turned on the radio? The heaters are going to heat, and they're going to apply high voltage. No. You've got to make this thing operate. So you got to get 12 volts over here for this to operate, or there's no high voltage. So if you got it backwards, I'm all turned around here. What's coming and going? So the 12 is coming over, and it would be connected wrong. It would be sitting on this, the 280 thing here. It'd just be sitting there. Wouldn't do anything. Wouldn't go anywhere. So you'd have the 12 volt supply to drive this stopped, and you have the high voltage supply hooked up over here. There's nothing there. There's nothing. So the result would be nothing would happen, and the radio wouldn't work. And there's no explanation for why there's a hole blown in this cable. That's just, I think someone suggested maybe somebody put a screw through it. Oh, it could easily be something like that. Sometimes you put these things back together and then you're screwing down the locking screws and stuff like that. And maybe a screw through the chassis, and inside there's a wire in the wrong spot and the screw goes right into it. That stuff happens. Wired backwards. Now if we look at the wires, the length of the wires, you can't trade them one for the other. This one's too short to get over here. That doesn't necessarily mean anything. I think this is original. I don't think this is wrong. That means the problem would be inside here, which means somebody would open this up. But look, see how soldered this is? Like these wires are soldered right into the bottom here. If you tried to pull this off, I don't think you could, because the wires are just stuck here and you're never going to get it off, I think. My repair did this in some way. I can't see how this could in any way affect it. So the only logical explanation at this point that fits is these wires are reversed, and that kind of thing, it just makes me perspire to think about it, because how could that happen? Wires are reversed, or I am just interpreting this thing all backwards. Well, what did I find when I looked for 12 volts? Did not find it in the pin that's supposed to have it. Coming from the radio over. It's coming over on this. I'm just going around in circles. So the same isolated pin, the one I have this in right now. We should find 12 volts on here. But instead we find it over here where we shouldn't find anything. It really is. Okay, I got to stop for a while, because the only conclusion that seemed to be coming through again and again and again is these wires are reversed. That just doesn't make sense. The claim is the last fellow to bench test this radio had it working on his bench. That's the claim. So if that happened, I don't know. I got to stop it, because I really am paralyzed here. So if for some reason the wires are reversed there, they would have to be reversed here to match, or the radio couldn't work. The report is the radio worked, so can I not look at this end of it and determine if the wiring is the other way around too? There's just no explanation for this, and it doesn't make any sense to me. And we're looking in this area again. It's so hard to see. So there is. Let's work on the lone pin here. The distal pin is running a red wire straight to this tube onto a pin all by itself. Onto a pin of this tube all by itself. Okay. The wire running from the pin straight to the tube. Oh my gosh, it's a different pin. It is different. Okay, just calm yourself down. Make sure you're not all turned around here. So, according to this, the 12 volts should come in on the distal pin and travel around here. But what I'm seeing is the distal pin, the one that's farthest away, the distal pin, is hooked up to the 280 volt spot. So that's two indications that this radio is wired in a unique way. Why would they do that? Okay, so to prove that, now the rest of the pins. Okay, so looking at this pin, it's a red wire and it runs, I would say, to the primary side of the transformer, and the other pin is the one that's just grounded right down. So we have one coming from here and the other one going over here. The one that's coming from here is this distal pin. The distal pin is this one. Didn't I pick up 12 volts on that? No, I did not. I picked up nothing here and got the 12 volts here. This radio is wired differently. How sure am I? So sure, I'm going to go and drink coffee and let a little bit of time go by, but I think I got it here. I think we're just going to have to pay no attention to the schematic and do our own thing here. Okay, I think we should try it again. Just close my shop door and keep the cats out of here while I do this because of the high voltage coming across here. So we're going to use the wiring as observed, not as listed in the schematic. Get this out of here. Okay, making sure this is high voltage now, coming into the distal pin. The 12 volts is finding its way to the radio right from here. There's no reason to send 12 over here anymore. We're not using the converter power supply here. This should work. Famous last words. Now we want to monitor the B plus voltage so I know for sure what's happening. Didn't I bring out clip leads for that? Yes, I did. Here's R. So we're going to clip this voltmeter right on to the B plus voltage that's coming over so we can monitor it so I don't go too high with it. And apply. I thought I had two clip leads. Blame it on the cats. The cats probably came and took it. Here it is. It's on the floor. I can still blame the cats for that. Okay, so we want the meter on ground. We best to use this ground over here. Okay, meter's connected. And the meter on. Okay. positive lead is here, positive lead up there. We're going to turn off the radio and turn on the power supply. Giving time for the tubes to warm up. Okay, now I've got the voltmeter right in the way of the controls. Let me put it over here. Funny voltmeter turns its light on all the time, and I don't know why, what it is that I'm doing. Okay, we're ready to turn on the radio, but only the low voltage to heat the tubes. There we go. We can watch the ammeter, at least I'm watching it. Okay, do exactly the same thing. So I think that's just fine. Hey, why don't we test? Oh, what happened there? Oh, so that's funny. It's not really funny. I grabbed this light and I was going to ground it out and make the light come on. And as soon as I started moving this, that thing reported a short circuit. We'll have to look at this more closely. Okay, but everything looks normal again. Got the right voltage over there, right current, tubes are heated, and we're ready here. So, okay, we'll turn the volume up quite a ways. I'm going to start turning up the B plus here. Let's see if I can get this high enough so you can see my hand on the controls. So we're watching this. We're going to raise this up to around 100, and I would think the radio would start making some kind of sound. Okay. So this time we don't get 14 volts here. That's good. Start raising it up. There it goes. Now I'm also able to look at this current meter up here, which tells me if there's too much load, like if there's a short in the radio or something wrong with it. I can figure that out. There isn't. She's behaving fairly normally. 18 volts. Oh, no. 29 volts. Drawing a lot of current. It's drawing 15 milliamps right now at 60 volts. Okay, 165 volts. And it's drawing a lot of current because they can afford to do that. This kind of radio, or maybe leaky capacitors. I don't know what. Let's tune it. Yeah, it's working. I don't have an antenna hooked up this time. Hey man, let's see if we can do that. Can we do that? Where's my antenna? Here it is. It is hooked up. The antenna is connected. The antenna is connected. I'm not sure it's turned on down here. Let's go tuning. Down here. Wow. What's all that noise? Now, do we dare push that bar? My poor little power supply. I don't know if we can do it. I don't think I'm going to push it. Test is over. Radio works. Good. Okay, very good. So I think all this radio needs, like so many car radios, new vibrator, and away she goes. I think that's the situation. Is there any reason for me to try this vibrator again in the radio? I don't think so, because I saw there was 12 volts on the pins and the thing was not operating. These things have a short life anyway, about 1,000 hours I believe, and the alternative is a fairly inexpensive replacement. No longer has a mechanical vibrator in it. It's done with electronics. Before I forget, I better turn off the high voltage here. Turn this guy off too. So there we go. That's it. My job here is done. Found a fault on a wire. Found out this radio doesn't follow the schematic. That's kind of weird. Found out the radio works if it's powered up properly. So I think that's all we got to do. Wow. Thanks a lot for watching. And tomorrow I'll be back to the radio I've been working on for a week and a half or so. A big, a gigantic radio. Thanks a lot for watching. See ya.